algebraic, this one when x means algebraic, x power 1. That means the n is 1. X, ex, dx. So you remember, when you want to use integration by parts, the formula is u dv equals to uv minus v du. So you have to know what is your u and dv. So for algebraic and exponential, the u is always the x. Okay, second one is the algebraic and trigonometric. Trigonometric means involve all this, all this. But I give you this sign, that means involve all. So if algebraic and trigonometry, then the u is still the x. Okay, then the dv will be the others. Okay, when you have x ln x, that is algebraic and ln, you remember this is the different case. Then the u is ln x. The rest, remember this one only ln x. Okay, then after that I will show you this example. So exponential and sine. So when exponential and sine, there is exponential and trigonometric. So when exponential and trigonometric, which one is the u? It's up to you. You can choose any one. You can choose ex, exponential to be the u. So if you choose exponential to be the u, then the dv will be sine x, bx. If you choose sine x to be your u, then the dv will be ex dx, up to you. And then later part, we are going to do this also. X arc sine x dx. Then the u is still the x. Okay, so you see, if you involve exponential, algebraic, the u is always the algebraic. Only when you have ln, then this one is special. Okay, can you understand this? You look at the x, you look at the u. The u is always the x. Only this one special case. Okay, so only when you see the ln, then it's a special case. The u is ln x. Okay, so this one you must remember lah. And then of course I'm going to show you the example after. Okay. Now you see I'm going to show you this. Sometimes you have to use twice the what integration by part. Now I give you two examples where you have to use the integration by parts 2 times. Like here, in this case. You see, when I want to integrate using this method, exponential, if I want to integrate using this method, you see cannot. Why? Because if I want to integrate like that, you see, this is x squared e negative 2x dx. Because when I differentiate this one, the bracket is here, I get negative 2. That means this x squared has to be pushed out. Then this is already wrong. That's why we cannot. Then here is negative 2 divided by negative 2. That means according to what we learned, it should be like this. Then it's exponential negative 2x plus c. But this is wrong because the x already outside. That's why we cannot. So if you cannot, because we have algebraic and exponential, we have to use integration by parts. Algebraic, exponential, integration by parts. So I told you already, when algebraic and exponential, the u is always the algebraic. That is x squared. U equal to x squared, that means this is the u. Okay? This is the u, x squared. And then you have du equal to 2x dx. And then the rest is your dv. So dv is e negative 2x. So you integrate the 1. Then here when you want to integrate, because the bracket is here, you must have a negative 2, then divide by negative 2. That's why you have v equal to negative. Then integrate the e, you still get back the e. Then you get this. Okay? Then after that, you just write down the bracket like this. Okay, x squared e negative 2x dx. Then this one is uv minus v, then du. You write down this one first. Then only you substitute u x squared. So this is the x squared. Then only you substitute inside. dv is negative half e negative 2x. v is negative half e negative 2x. Then du is 2x dx. That's why you get something like this. Then the 2 and the 2 you can cancel. Cancel, you simplify. So you get this one, you get this. You get something like this. And then here you get this. Again here, now I want to integrate. But if I want to integrate this again, because the bracket is here, the bracket is here, so when I differentiate this, I have negative 2, isn't it? So again, this one has to be pushed out. So again, cannot. So what you do, you have to do another one time. That's why I said sometimes you might have to use more than one time. So again, because algebraic and exponential, this is your u. So the u is x, dv is this one. Then you du equal to dx. Then dv will be this one. You want to integrate this like just now. Differentiate this, you have negative 2, 1 over negative 2. So you have this. And then after that, you substitute again. You see, I write down uv v du. I write down this one first. Then only I fill in like that. One by one. Okay? So therefore, now you just simplify negative half, something like this. Then this one also negative half x, e negative 2x. Then this one, when I simplify, I take out the negative half, become positive half. Then e negative 2x. So to integrate this negative 2x, again the bracket is here. Now I just need to add negative 2. But now I don't push out the x already, isn't it? So this is correct already. So this one is negative 1 over 4 e negative 2x plus c. So this is the answer. Or you want to factorize, you want to take out all this, you factorize, then you get this. Then this is the answer. So you see, you have to use integration by part two times. Why? Because this is x squared. One time you still have the x, then you have to do one more time. Okay, now I show you another example where you need to use the integration by part twice. So not only sometimes you have to use twice. Okay, here is exponential and trigonometry. Okay, so you see we have done this. We have done algebraic, exponential, algebraic, trigonometric, algebraic, logarithmic. We have done this. Now exponential, trigonometric. Now combine these two. But I tell you, we don't have exponential and logarithmic. We don't have this. Or trigonometry with logarithmics. No, we don't have this. We cannot combine these two. You combine, I don't know how to do also. Exponential and trigonometry also cannot. Okay, so we have algebraic, exponential, algebraic, trigonometric, algebraic, logarithmics, or exponential, trigonometric. That's all. No more. Okay, now look at here. So in this case, still I want to use u dv equals to uv minus v du. So in this case, which one you want it to be your u? It's up to you. Okay, that's why just now I give you already, I say it's up to you. When we have exponential and trigonometry, you can use either one. If you use exponential to be the u, then the dv will be sine x dx. If you use sine x to be your u, then it will be ex dx. Okay, up to you. It's free. So in this case, of course, you have to choose one. Okay, in this case, I choose the u to be ex. So the u is ex, then the du will be ex dx. And then here dv will be sine 2x dx, then dv I integrate. So you want to integrate this one, 2x, you must have a 2, so half. Then you can integrate. So half integrate sine, you get negative cos, isn't it? You will get negative cos. So this is what you get. Then after that, you just write down the bracket. So you just write down first uv v du. Like what I said just now, you leave the bracket. You draw the write the 4 bracket first, then only you fill in. Okay, u is ex, v is this one, v is this one, then ex dx. Okay, so remember every time you write down the 4 bracket like this first. If not, I scared you might make mistake. You write, then only you fill in. Okay, so once you fill in, you have all this. You see, you have this ex sine 2x. This one is negative half ex. Then negative become plus ex cos 2x. Okay, so when you come to here, you see still exponential trigonometry. Exponential trigonometry. So you still have to use another one time the integration by part. But here, because just now we have already used u as ex. So here still you have to stick to that. U is ex. You have to stick. You cannot change, because sometimes you change, you might get different things. So once here already fixed, the first time you use u is ex, second time also you fix it. Okay, then the dv will be cos 2x dx. Then this one you differentiate, you get this. So this one you integrate, you get v. Then here, because the bracket is 2x, then you must have a 2 half, integrate cos, you have sine 2x. Then why you get this. Then you substitute, you see, negative half, and then plus half, okay, half, and then here you see half, this part, uv, I write uv first, I haven't filled in yet, I write uv first, minus v du, like that. Okay, I write like this first, uv, then v du. So you write down the 4 bracket, then only you fill in u, v, v du, then only you fill in everything. Okay, then after that you simplify, e sine 2x, you see this is e sine 2x, okay, negative half, this one, then this one is 1 over 4, then e sine 2x, isn't it? Then minus, what is this? Half and half, you get negative 1 over 4. Then here you have e x sine 2x dx. So this one already completed, isn't it? You get the answer. But still you see another one, exponential trigonometry, isn't it? That means you still have to use one more time, is it? U dv, correct or not? But no need. Because why? You see, this one and this one is the same one. Is it the same? They are the same. This integration and this integration, they are the same. So you can bring it over here. Then when you bring it over here, it's become plus. So you see plus, then you have this and you have this. Okay? Then after that, when you add these two together, you have 5 over 4, this one. Then you get this, isn't it? Plus c, alright? Then after that, the 5 over 4 you bring over, you get this. Okay, then after that you can factorize, you take out the ex, 1 over 5, then you get this. So this is the answer. Okay, so you see this one we need to use twice, integration by part. So you when you do the question, certain question you have to do twice, you do. Okay, I think the most is twice. I don't come across where you have to use 3 times. The most is 2. But here, of course, you must be able to see this one and this one is the same. This one, wait. This one and this one is the same one. Okay, if you cannot see, then you go and keep on, you go and differentiate this again. Actually, they are the same. That's why you can bring them together. Okay.